Hey, how you doing, superhumans? Welcome back to our new lecture. And in this lecture, we will be covering another type of ICMP message, that is source quenching. So basically, quenching is an English word, a common, very common English word, which basically means to quench someone's thirst. Quench, that's a very common phrase whenever we say that, quench someone's thirst. Or the basic meaning of the exact meaning of the word is to rapidly cool down a hot substance. So let's see how this particular word is going to be coming into use whenever we are sending a source quench message to the sender. So let's say that the source is sending an IP packet, and the IP packet is then sent over here. Then this IP packet is sent to the router R3. Now this IP packet, the source is not just sending one IP packet. The source is sending a lot of IP packets. Let's say within a particular time, let's say within 1 second, the source is sending. This is just an example. This is not an actual case. Let's say that the source is sending 1,000 packets in 1 second, and this router R1 is also able to take in 1,000 packets in 1 second. This router R2 is also, this router R1 and this router R2 both are able to take in 1,000 packets in 1 second. But when these 1,000 packets reach R3, then R3 is not capable of taking in 1,000 packets in 1 second. So basically, this router R3 is going to send back an ICMP message to the sender telling him that source quench, that you need to slow down the pace at which you are sending me the packets. This is the complete thing, the complete meaning of the ICMP message of type source quench. So this ICMP message reaches then router R2, then router R1, and then the sender. This is the way the source quenching message mechanism works. So basically, there are certain points that I would like you to remember. The first point is that the type number of the source quench message is 4 and the code is 0. Then, since it is here, the router R3 is not able to take in 1,000 packets in 1 second, there can be n number of reasons for that. One of the reasons for that could be that there is a network congestion. Now, network congestion could be a lot of things, that lot of reasons. This router R3 is not just connected to the router R2. It is also in connection, let's say, with router R7. And this router R7 is also sending packets to it. Then this router R3 might be in connection with some other routers as well. Let's say router R100, and this router R100 is also going to send certain packets to him, router R3. So like this, there is a overload of packets that are coming over there at router R3. So because of this, router R3 could not take a lot of packets. What we call this particular thing as network congestion. The keyword for this is network congestion. The second keyword could be that router R3 is simply not that much capable of taking in 1,000 packets or sending and taking in 1,000 packets in 1 second. The reason might be the hardware issue. The hardware of router R3 is not that much capable of taking in those many packets. So basically, source quench message takes care of congestion control. The reason for that is, how is it taking care? Once router R3 sends an ICMP message that there is a source quench, you need to quench your sending of the packet. You need to cool down, bro. Cool down. Sender S, cool down. Slow down your pace of sending me the packets, Okay. So what sender S is now going to do, it is going to decrease, let's say, the speed of the sending of the packets. Let's say now the packet speed is 900. So because of this, the number of packets that will be sent at each particular node will be decreased. So can we say that there would be a decreased amount of congestion in the complete network? So this is the way ICMP source quench message is helping in the congestion control. The second thing is flow control. Obviously, It is helping in flow control as well, because if 1000 packets are coming over from here and R3 is not able to process all those packets in that much time within 1 second, so there would be a flow inconsistency from R2 to R3 and then from R3 to D. From R2 to R3 1000 packets are processing, then from R3 to D only, let's say the capability of R3 is 500 or 900, only 900 packets are processing or moving forward. So this is basically a flow inconsistency of the moving forwarding of the packets. So ICMP source quench message is going to take care of that by making sure that router R2 is also going to send only 900 packets to router R3. Okay. Then the third point that you need to remember, and this is a particular shortcoming of source quench ICMP message, that is that for each packet that is discarded by the router R3, an ICMP message of type source quench will be sent. If router R3 is discarding the packet because it cannot take in, it cannot process those packets, then for each packet discarded due to the source quench reason, it is going to send an ICMP message. Even if the packets are coming from the same sender, let's say 1000 packets are coming from the same sender, and when these 1000 packets reach R3, it is not able to process as these many packets, then the number of packets that will be discarded by R3, the same number of ICMP messages will be sent back to the sender S. If router R3 is discarding 200 packets of sender S, then it is going to send ICMP message of source quench type to the sender S. 200 ICMP messages will be sent if 200 packets are discarded. This is a shortcoming. The reason for that is, I have written the problems with the source quench message. The reason for this shortcoming is that instead of sending 200 ICMP source quench message, the router R3 could have sent just one message telling the sender S that you need to source quench. You need to cool down, bro. You need to slow down the pace of your packets, bro. So this has become a rhyme now. So it could have done its case with just sending one ICMP source quench message, and it would have also helped the network in tackling the congestion, tackling the network congestion. If the router R3 just sent one ICMP message for all the packets that it discarded coming from the same sender, then it would help in the tackling of the network congestion. But over here, since it is sending the ICMP message for each packet discarded by the same sender, sent by the same sender, then definitely that these all remaining, let's say if 200 packets are discarded, 200 ICMP messages will be sent, but remaining 199 are of no use. So sender S would get to know about that it has to lower down its pace with just one ICMP message. This is one shortcoming. The next shortcoming is that once the sender knows that it has received a source quench message from the router R3, it is going to decrease its pace of sending the packet till the time it does not receive any more ICMP source quench messages. So what I mean by that is, let's say this is sender S and this is router R3, not making the other routers in between. So let's say the capability of this router R3 of processing the packets is 500. So when this sender S sent 1000 packets, then router R3 is going to send, it will come through this path. I have directly shown it like this. So this ICMP message will say that this is a source quench. So sender S, the next time it is going to send 900 packets. Sender S has decreased the pace. Router R3 again is going to send the ICMP message, just source quench. Sender S would decrease the pace further. It is going to decrease the pace further till the time the pace does not match the router R3, and till the time there is no more source quenching messages coming from the router R3. So we can say that it has decreased the pace. But let's say that there comes a point where router R3, let's say that this decreased capability of router R3 of just processing 500 packets was due to network congestion. And at a particular point, this network congestion decreases. then R3 can take more number of packets, let's say 700 packets at a particular time. But since S is going to send the packets with the decreased pace, with the final decreased pace, which was 500, so it is basically waste of the resources. What could have happened, what should have happened was, again, a message should be sent from the router R3 that now the network congestion at router R3 has decreased. Now you can increase your pace. But this ICMP message is not sent. The ICMP message is sent only for decreasing the pace, but never it is sent for resuming the pace that sender S had initially. The third shortcoming of ICMP source quench messages, for one-to-one case, let's say that this is the router R3 and this is sender S, and router R3 is receiving the packet from the sender S through this path. Then if it is a one-to-one communication, which means that only router R3 is receiving the packet just from sender 1 through these nodes, just from the sender S, then it is very much okay, because if it is telling that you need to decrease your pace, then sender S will decrease its pace. But let's say router R3 is not getting the packets just from sender S. It is getting the packets from sender S1, then from sender S2, from sender S3, from sender S4. And let's say the sending packets, the frequency of sending the packets of sender S1 is 1000, of this is 200, this is 100, and this is 400. And router R3 can only take, let's say, 500, 800 packets, or it can process, router R3 can process only 800 packets at any given moment. Now, since all of these senders are sending the packets at the same time, R3 would send ICMP message of type source quench to any of the senders, to any one of the senders. So it could be a possibility that router R3 is sending a source quench ICMP message to sender S2, and then it would also not do the work, because the complete output of this is 500, 700, 1700. Just telling the sender S2 that you need to decrease your pace won't do the work. It has to tell the same thing to sender S3, then S4, and then S1 as well, because the just telling S2 won't do the work. So like this, router R3 cannot decide to which particular sender it should send the ICMP message if it is a many-to-one conversation. If it is a many-to-one communication, then router R3 cannot decide to which particular sender it needs to send the ICMP message so that it matches its capability. This is the shortcoming of the ICMP message of type source quench, because there can be a point, the best thing that our R3 could have done was just sending an ICMP message to the source S1, and this would have done the work. But now, since it has sent it to source S2, its capacity of 1800 is still not matched. The other senders have to decrease their sending pace more. So it has, router R3 has to again send the ICMP messages. So this is one of the shortcomings. I hope that the complete lecture would have made sense to you. And if you have not understood some of the points, then I highly suggest that all the points are discussed in really great depth. You must watch the lecture again. Bye and bye. Also, before ending the lecture, I want to talk about these things, that in each of the slides that I make, I write these codes. I write these codes to make sure that you keep on working hard in your life. So make sure that you read these codes in each video that I'm making. Bye.